Here we're going to look at the incomplete contracting case with the contingent renewal model. So this labor discipline or contingent renewal model that we described in the previous video and then spoke about the complete contracting case of, we're now going to talk about the incomplete contracting case of. And what you want to think about here is that we're going to have a structure that is very similar to what we saw in chapter 10. And we're going to see that the agent is going to have ISO value curves. With those ISO value curves, what's going to happen? They're going to use those ISO value curves to derive a best response function. With the best response function, we're going to see that the best response function is the incentive compatibility constraint on the principal minimizing their costs. Okay, so we've seen this figure before. Here we have ISO value curves for the agent. And the value curve where V is equal to 0, that is going to be the agent's participation constraint. The other ISO value curves, what are they showing us? They're showing us curves on which value is constant. So therefore on ISO value curve V3, G, E, and F is telling us that all of those points provide the agent equivalent value. However, what we don't know is which of them is the best response. To derive which of them is the best response, we have to find which point for a given price or wage offered by the principal, the employer, basically results in the highest value for an agent. Now we know the slope of the ISO value curve is going to be equal to the negative of the marginal rate of substitution, which here is equal to minus VW over VE. Okay, so how do we find the wage and the level of the effort the principal and agent will exchange when their contract is incomplete? We described the steps earlier, but we're going to highlight them now. So as in chapter 10, like we said, the worker has this value function, V as a function of wages and effort, where wages are on the horizontal axis and effort is on the vertical axis. And when we think about this, why does the worker prefer a higher wage but not necessarily less effort? So the wage, what do we think there? The wage is always a good, a bad. Which one? For effort, is effort a good, a bad, either, both? How does it work? So think about that for yourself for a second, pause the video and try and remember how this works. Okay, yes. So wages are always a good for the agent. Wages just add to the agent's or the employee's or the worker's utility. Wages are a good. Now effort, E, is a little strange. Why? When we think about effort, effort does two things. Effort adds disutility for the agent. It's effortful to exert effort. But second, having higher effort results in a longer contract. Okay, the likelihood that you're going to be continued to employed is going to keep up. Okay, it's going to stay higher. And so what that means is that effort moves from being a good when the ISO value curves are downward sloping. So over here, they're downward sloping, notice. And so effort over in this range is a good. But then if we go up and up and up on the ISO value curve, effort now becomes a bad. Okay, what's happening there? The disutility effect dominates what happens when the effort, well, the increasing effort still is increasing the lifetime of the contract, but it's adding more and more to disutility. Okay, so now we use these points to derive a best response function. So notice what's happened here. We've added points D and N, and then with adding points D and N, what's happened? We've looked at vertical lines corresponding to a given wage, and with those vertical lines with a given wage, what happens? We see that at the ISO value curves that are tangent at those given wages, we find the point on the ISO value curve that is a best response to that wage. And so those best responses give us the best response function. Now, why is that happening? Recall that the slope of the ISO value curve is equal to VE over VW over VE, which isn't super visible right there. It's a little blurry, I'm sorry. And so VW over VE, what's the important thing there? We know that when the agent maximizes their utility, what's happening with VE? VE is going to be 0. That can only be true when they take their first derivative of their effort with respect to E, and that VE equal to 0, that's only happening when the slope of the ISO value curve is undefined. Okay, so VW over VE, that can only happen when it's vertical. Okay, So just reminding ourselves that we've got to find the Nash equilibrium effort and wages. We've got the ISO value curves. We then think about what the individual does, and we see that the best response function is going to be the incentive compatibility constraint for the agent on the principal's maximization. So then what we have to think to ourselves is here, this best response function, E as a function of W, is what the effort is that the worker will choose given the wage that the principal offers them. Each of those choices of effort is going to be a best response to what the principal offers. So then what's the principal going to do? Like we said previously, what they're doing is they're choosing an ISO cost curve. So C1, C2, C3, the slope of the ISO cost curve is equal to E over W, the effort that they receive for the wage that they pay. They're trying to minimize that thing, and that is minimized as the ISO cost curve is higher. Just to remind ourselves of how this works, if we compare these three ISO cost curves at a wage of $10 an hour, and we choose points A, B, and C, it's going to be cost minimizing for the principal if they have chosen that wage to choose the ISO cost curve C1, because C1, why is that a lower cost? Because they're getting higher effort for the same wage. Okay, now this is what they would want to do if they were not constrained at all. They'd be trying to get as steep a curve as possible. Steep, 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 right? But the thing is that we don't yet have the constraint in this figure. So what's the constraint going to be? The constraint is going to be the agent's best response function, which is the incentive compatibility constraint on the principal's behavior. Okay, so when we're thinking about this, we're just describing exactly what I've said. We've got the worker choosing E based on their best response function. The principal is going to choose W based on the ISO cost curves. And the employer is caring about the amount of effort that they get from a worker for every euro, every dollar, or every pound that they spend, such that they're getting E per W, effort per dollar that they spend. And E over W is the slope of the ISO cost ray for the employer, as we've already said. Okay, so bringing this all together, what do we get? We get the figure in 11.3 in chapter 11. We've got here a variety of things. We've got the agent's ISO value curve at the Nash equilibrium. We've got the agent's or the employee's best response function. We've got the employer's ISO cost curve that is tangent to the best response function in purple at point N. So we've got that tangency at point N. We then have a Pareto improving lens in yellow here, and point F is a Pareto superior point to the Nash equilibrium. Okay, so just to remind ourselves of what's going on there, we've got the employer's steepest ISO cost ray, that's tangent to the incentive compatibility constraint. Here the employer will choose C2 given the best response function, E as a function of W, of the agent. This point N, the Nash equilibrium, is where the slope of the ISO cost curve is equal to the slope of the incentive compatibility constraint. So what does that mean? It means that E over the wage that they get for each unit of effort is equal to delta E over delta W. Okay, so the solo condition is the rule that tells the employer the wage that will minimize the cost of his unit of effort. So using the solo condition, the employer implements marginal rate of substitution equal to marginal rate of transformation. So we've seen this previously. So what is the employer doing? They're choosing the point N, where their marginal rate of substitution, which they're getting from the slope of their ISO cost ray, okay, is equal to the marginal rate of transformation, which comes from the agent's best response function, which is the incentive compatibility constraint on the principal's cost minimization. And so what we have to think about is at point N, what's happening? MRS of the principal from the ISO cost ray is equal to the MRT defined by the agent's best response function. Now, we then have to think about, in order to diagnose whether this point is Pareto efficient, as is asked in the question, is this Nash equilibrium Pareto efficient? What do we remember from chapter 10? What's the condition that we're going to have to think about to determine whether the Nash equilibrium is Pareto efficient? See if you can remember that for yourself, and then we'll explain it very briefly. Okay, so let's think about it. At point N, what is happening? MRS is equal to MRT, right? MRS is equal to MRT at the Nash equilibrium. Now, what's the problem though? We've got the agent's ISO value curve at the Nash equilibrium, and at the Nash equilibrium, what do we know the agent's marginal rate of substitution is? It's undefined at point N because it's vertical at that point, the ISO value curve. So that means that the agent's marginal rate of substitution cannot be equal to the principal's marginal rate of substitution. The worker's marginal rate of substitution is not equal to the employer's marginal rate of substitution. What that means is that there are alternative points that they're both willing to pay for because their marginal rates of substitution are unequal, where they can both do better than the Nash equilibrium. Point F is one such point. Okay, so we've highlighted point F, and point F would be on a lower ISO cost curve for the principal and a higher ISO value curve for the agent. And at point F, both of them would be doing better. The entire Pareto improving lens in yellow shows every single Pareto superior point to the Nash equilibrium. So, contrasting the two figures, we've got MRS equal to E over P over in here. We've got MRS equal to E over W, which we can't quite see here because of the overlapping figures. We've got to think, what is the agent's participation constraint in each context? Well, in the lower figure, you can see here that we've kept point C just to show you what's happening there. And so the agent's participation constraint is UE equal to 0 up here. Okay, so U0 equal to 0 over here. That's the agent's participation constraint. Then similarly here, what do we have? We've got the agent's participation constraint depicted as an ISO value curve in the lower figure. So just remind yourself, that is what the agent would receive if they were at their fallback position. Okay, so the wage and the effort level given by the Solow condition. The Solow condition comes from Robert Solow, as we'll comment on a little bit later. They're the Nash equilibrium of this labor discipline model. And what's happening there is we just have this condition that the marginal rate of substitution equals the marginal rate of transformation, and this very important point that the effort per dollar that is paid, or the wages per unit of effort, if we invert that, that what we have there is a condition for a Nash equilibrium. The agent is best responding and the principal is best responding. So for the wage, given that the worker has adopted the strategy described by her best response function, the best the employer can do to minimize their costs is to basically minimize the cost of effort for a given wage. Okay, so what they're doing is they're choosing that point. So for a given wage, how can I get the highest effort for that wage? What does that mean? Choose the steepest ISO cost ray. That's what that means for the employer. And then for the agent, what are they doing? They're thinking, given the wage, what is the best response effort for me to exert, given that I want to maximize the value of the lifetime of the contract to me with this employer? So what are you having to do there? You're having to think about the benefits of increasing your effort in terms of increasing the lifetime of the wage, but also there's the disutility of the effort in terms of thinking about that increasing up to a point where the disutility is getting worse and worse and worse, and that's worsening the value that you receive overall. So you're balancing those two things in terms of choosing your best response. Now, putting these things together, these basically complete the first step for the labor discipline model. We haven't yet determined the number of hours that the principal or the employer is going to hire. We've just determined the Nash equilibrium level of effort. So a couple of questions you can reflect on for yourself. I'm not going to answer them, but I think you should try to answer them yourself. Is how do we know that the combination WN-EN, the Nash equilibrium wage and effort, is a Nash equilibrium? What does it mean for that to be a mutual best response? Okay, see if you can answer that question. And also, suppose an unemployed worker went to the employer and promised to work as hard as the current workforce did, the current employees, and they also say, okay, but pay me $1 less an hour. What would the employer say to that worker? Okay, now to answer this question, think to yourself about what that best response function is. Okay, if all the workers are identical, what do you think this worker is saying? Do you believe this worker? Why or why not?